Hey, physics class, last video, momentum and impulse. We're going to look at, again, some of our practice questions here. On practice sheet number 2, I'm going to go over 7 and 8, and then I'm throwing in question 11 from that original practice sheet as well. So 3 more questions to kind of go through in this last video. All right, let's get started. Let's bring this up. All right, cool. Question 7. A mud blob of 0.35 kilograms, okay, is thrown at a wall at a velocity of 10 meters per second, okay? The blob just sticks to the wall, so instantly sticks to the wall. What is the change in momentum? So basically, if it's going from a velocity of 10 meters per second to nothing, because it hits the wall, what's that change in momentum? All right, well, let's find what the momentum was to start off with, and then that's going to be the change because it gets to 0. So, momentum at the start would be just 0.35 times 10. So our momentum, 3.5 kilograms meters per second, and that will be our change. Okay, so that will be our change in momentum. Second part, B, so that's 8. If the wall exerts a force of 20 newtons, how fast does the mud blob actually come to a stop? So if when the mud hit the actual, when it actually hit the wall, if it actually exerted a force of 20 newtons, how fast does this thing totally compress and stop? How much time did that take? Well, that change in momentum is my impulse, so I have 3.5 as an impulse equals 20, that's my force, multiplied by time. So divide by 20, divide by 20, and my time is going to equal, what do I got here? 0.17 seconds. All right, that one's a pretty easy manipulation. No any special add-ons in the sense of direction or any kind of force of gravity. Nothing else there. So that one's pretty straightforward. All right, let's go to question 8. Question 8: a car has an initial speed of 30 meters per second. We're in 30 meters per second already. Nice, no conversion. If she applies the brakes at an average force of 20,000 joules, how long will it take to stop the car? So almost exactly the same type of question as before. I have an initial momentum. I need to obviously apply some kind of impulse to stop the car. That impulse is going to be the exact full change in momentum because I want this to go all the way down to 0. So momentum at the start is 1,200 times 30, which means I believe I get 36,000. Yeah, 36,000 kilograms meters per second, and that is my change. I want it to come to a complete stop. If it comes to a complete stop, that means the momentum is 0. So I need all of that to be my change in momentum, which means that's also my impulse. My impulse equals 36,000. And again, I wonder how long it takes to stop the car. If the brakes, I got here, equals, if the brakes are able to do a force of 20,000, okay, joules. All right, I don't know why I put joules there. Let's change that. That should be newtons. I will change that right now. Okay, how long will it take to stop the car? Okay, so force is 20,000 multiplied by time. Okay, so divide, and cool. That means our time is going to be 1.8 seconds. 1.8 seconds. So that's how long it took for this car to actually stop. Okay, very similar to our last one. All right, last question. We're going to switch over to practice sheet number 1. Practice sheet number 1. I've already got it on here though. And so question 11. It says Jolene. Let's move this a little this way. All right, Jolene is pushing a 40 kilogram box. Mass equals 40 kilograms. With a constant force of 65 newtons for 5 seconds. Okay, if the box is already moving, so VI equals 1.5 meters per second, what will the speed be after 5 seconds? So assume there's no friction right now. So basically this Jolene is applying an impulse. She's applying a force over a certain time. So what is my impulse going to be? Force of 65 times time of 5 seconds, which gives me an impulse of 325. So that impulse is going to be, again, a change in momentum. And so if I have a change of momentum, I can figure out what, like the change in velocity is going to be. Not the final velocity, but the change in velocity. So my change in momentum equals 325, which means if I take that equals mass of 40 times velocity, and this is going to be a change in velocity. So divide by 40, I get, what do I get there? 8.13, 8.13. Now that is my change in velocity, okay? So many students like to just stop there. Woo! Found the new velocity. That is not the new velocity, that is my change in velocity. That is how much I increased. So all I have to do to actually get final velocity is take my initial, 1.5, plus my change, and I get a VF of 9 point something, 9.63 meters per second. Okay, again, not too bad of a question, I think. Just again, a lot of students unfortunately stop here because they think that this is the final velocity, when again, that is our change in velocity. That is the impulse you put in, so that's the change. Got to make sure that we have that front part added in at the end. Okay? All right, I think it'll be good. Next week we'll have a little bit bigger of a section going on the conservation of momentum. We did that a little bit in our lab when we looked at some collisions and what happens before has to kind of equal to after. But we'll be good. But thanks so much, class. Got started with momentum. Good start. All right, have a good day.